Good morning, good day, good evening. This is Steve Garrison with Stellar Cyber. We're going to talk about nipping ransomware in the bud with Open XDR today. My colleague and I are going to walk through some slideware and a demonstration to show you the power of our XDR kill chain and incident correlation in helping you tackle the worldwide problem of ransomware. Daniel Chang is going to lead that discussion once we get through a couple of slides. First, let's just talk about what Stellar Cyber thinks XDR means. Many of you are seeing a lot of noise out there in the market about XDR and Open XDR. What's it really all about? Well, for us, X follows the tradition in networking and IT technology that it means anything. We are not here to talk about extending detection and response. We are here to talk about the promise of XDR, which we think means covering your entire attack surface, whether it be in the cloud, network, endpoint, or user. That's why we think X means everything. I'd like to turn the microphone over to Daniel now, who's going to walk us through some preparation slides so you understand the platform before we do the demonstration. Daniel, why don't you walk us through this first slide?
Yes, thank you, Steve. Yeah, so Stellar Cyber's Open XDR platform, as Steve mentioned, it's really about being able to detect and respond and be able to ingest all of the different data sources. So out of the box, we have over 150 plus detections, and these detections are all automatically correlated. We also have over 150 plus types of ingestions. So integration that we have built either through custom parsers as well as API connectors. So that's the most important thing at the initial stage, is to get the right telemetry from the entire attack surface. Once we have the data on our platform, that's where we leverage our machine learning to do the automated detections. And why that is critical is that as much as we can automate the whole process, that is eventually going to reduce the time, the mean time to detection, as well as mean time to response. And as a result of that, we're actually going to be able to help you reduce costs and really simplify the operation in your SOC world. Hey, Steve, is there any question in the chat tool?
Actually, there is, Daniel. It's a great question. The first customer is asking, sounds like a good story, but how hard is this to bring up as a system? And I think they're thinking of SIMs, Daniel, where it could take months to tune and get the rules set up and things of that sort. How about in our case? Can you walk us through a basic installation and how fast can it be up and running and showing these wonderful results?
Yeah, sure. This is a very common question. So in terms of the deployment, there's really two main components to the platform. The first thing is the data processor. So the data processor, it is the brain of the platform where all of the ingestion of the metadata from all of the different telemetry gets ingested. That's where the normalization and enrichment, actually, takes place. And then machine learning also takes place. So that's the very first component, and that can easily be set up, typically, within, half an hour or so. The second, component would be the family of sensors that you want to deploy to collect the right type of telemetry. So we can ingest like your, SaaS application, any of the API connectors, as well as, forwarding your syslog, from your, security tools into the platform. So I ran many different, POCs. And typically within, I would say within about 2 to 3 hours, you will be able to get, everything, set up.
That's great, Daniel. I think that's very helpful. Let's go to the next slide and see if more questions come in.
Sure. So we talked about, getting the telemetry, across the entire, surface. And the reason why is we want to be able to provide you with the full visibility. So in terms of, visibility from the network, we tie in with many of the firewall, vendors. This is just an example that, most recently, we have also, ingested the F5, firewall. in terms of the endpoint EDR solution, we also are able to ingest, the CrowdStrike, the Cylance, SentinelOne, and many of the EDR vendors out there as well. And likewise, for the cloud application, identity, and apps, so we can actually get, all of these different telemetry into our platform. Now, once it's in our platform, because of the fact that these different data sources has, different formats, in order for machine learning to leverage all of these telemetry, we need to, feed that through a normalization process. So we normalize the data, we enrich the data with, our machine learning, as well as, geolocation, and also our threat intelligence, to then, produce a standardized record, which is what we call the interflow. And once we have that interflow record, that is where our machine learning takes over, right? So our machine learning has supervised and as well as unsupervised learning. We've also added the graph machine learning, where we no longer just produce and trigger alerts. Now, with the graph machine learning, we are actually able to correlate alerts together into a single incident. So that is actually a game changer, because most of that functionality today in the SOC world is done manually by the SOC analyst. And what we can also do is that, once the detection has been triggered, we have many different response capability out of the box. We can, send any of those alerts and incident to your, SOAR, platform. We can also take response capability, such as, blocking it on the firewall. We can contain the host, using our EDR solution. And a lot of our customers also are opening up a ticket, through the integration with like a Jira or a ServiceNow. Any question in the chat tool, Steve?
Yeah, actually there is, Daniel, and I think it's a good for clarification on this slide, it turns out. So this idea, they're asking this idea of sensors versus logs, packets, and file information, and you can kind of see how they pull together to give you the attack surface. How do we sort out who needs a sensor, or can you just logs be enough, or a packet's enough? How do you help a customer walk through that decision matrix?
Yeah, so typically what we would like to see is really all of your traffic, meaning the north-south traffic typically would be covered by the perimeter firewall. So we will be able to get the logs from your perimeter firewall. So that will cover the north-south traffic. Now, for the east-west traffic, that's really where a lot of the lateral movement, insider attack, if we don't have that visibility, we are really missing out on, a lot of the, potential triggers of security, breaches. So in those cases, that's where you would want to be able to place like a network, or a security sensor, and give us a span port. And so then what we were going to be able to do is we're going to be able to process that network traffic, extract the metadata, feed all of that telemetry, to our data processor.
Great, Daniel. I think that's really helpful. Why don't we go on to the demo and show some real, not slideware, but software?
Yeah, no, definitely. What you're seeing here is the brand new innovative UI that Stellus Cyber has pioneered. In this dashboard, you will see the XDR kill chain, which is represented by the loop. In this XDR kill chain, we really have simplified it to 5 different stages. Why we feel that it is necessary for an XDR kill chain is that let's say take, for example, a port scan. If the port scan originated from the external source outside of your network, that is really a reconnaissance or initial attempt. Now, if the attacker has already come in and compromised one of your devices and is looking to port scan the other internal asset, in the old model, it also puts that alert in the reconnaissance stage, which is the first stage. So that's the reason why we feel that having this XDR kill chain, you can see that we have then put the internal port scan as part of the exploration stage. So I can kind of like drill into the stage to show you what I was talking about. So if I go into the initial attempt, if you go and look at the reconnaissance, so these are the tactics, and some of these tactics are the MITRE attack tactics. So like the reconnaissance, resource development, credential access, initial access. So these are all MITRE attack tactics. Anything that is prefixed with XDR are additional tactics that we feel that are actually missing. So we're really enhancing this whole XDR kill chain. So back to the reconnaissance, you can see that one of the alert types is the external port scan. And this is coded into the initial attempt stage. Now, if I have an internal port scan, you will see that the internal port scan, it is under the exploration stage. So this is the internal port scan, and it's part of the exploration stage. The tactic that is used is discovery. So that's one of the many reasons why we feel that there is actually a need to have this new kill chain. So let me just go and explain further. As part of this whole XDR kill chain, you can see that we have out of the box 155 alert types. And if I check the initial attempt stage, what this is showing you is that I have 49 available alert types in this stage. And in the past month, so you can change this time interval, but in this past month, 22 of these alert types out of the 49 was actually triggered. So you can scroll down and see all the different alert types and which are the ones that was actually triggered. And if you want from here, if you want to drill into the detail of these alerts, all you have to do is just click on this view button, and you will see a lot more details in terms of, okay, this particular alert type, which is the external user agent anomaly, it is part of the initial attempt kill chain stage. The tactic that is used is XDR and network behavior analytics, and the technique is the XDR user agent anomaly. So let me just go back there. So as you hover over into the different stages, you can see all the different tactics that are part of the stage. So the second thing that I want to talk about is the incident correlation. As I mentioned earlier on, SOC analysts today has to piecemeal every single alert together. What we have done with this new release of the UI is that I've got now under my left panel, the top incident. So if I drill into the dark side incident, what you are seeing here is a graph. And this graph is produced by our graph machine learning. And this shows the correlated alerts into a single incident. And how do we do that? It's by looking at some of the common entities. The entities are like the host. What are the hosts that was involved in this incident? what are the processes that were involved, what were the URLs, and the users. So as you click on the numeric indicator here, that's going to show you the alert type, okay? And we also have a timeline view that shows you the progression of this attack. So you can see here that we started off with a phishing URL detection. 3 minutes later, we have an internal Trojan. So as you move down the alert, you can see that the graph is highlighted with where the alert actually happens. So by simply just looking at this timeline of all these different alerts, this definitely looks like a typical ransomware, where it starts off with a phishing URL detection, with internal Trojan being deployed, RDP, all the way to internal SQL dump file execution and the volume shadow copy. Now, you also have an option to drill further into and investigate any of these alerts, by clicking on the more information. And yes, you can see from here, for every single alert that we generated, we will show you what are the key fields that was used to generate that alert. And now looking at this further down, we are essentially looking at the interflow record, where we will display the application that we detected was MySQL. Where did we source this data from the sensor? We will tie in with our geolocation as well as our threat intelligence. And with the XDR kill chain, if you go further down in the interflow record, you're actually going to be able to see all of the details with regards to the XDR. So if I scroll further down, you can see that this particular alert was coded with the tactic ID TA0009. The technique name was collection. The technique ID is T1074. So these are all MITRE ATT&CK compatible. Okay, that ends my demo. And Steve, back to you.
Well, thanks, Daniel. We actually have a couple of questions, so perfect timing.
Oh, okay.
Yeah, no, it's that was a great overview, Daniel, and very helpful. First one is pretty basic, but I think it's such an obvious question. We need answered for everybody else, and I thank this one person for asking. Why the loop, Daniel? We've got the loop graphic there. What's the loop all about? There must be a story. I know the answer, but
yeah.
Just share for the audience.
Yep. So like I mentioned, in the old cyber kill chain, it was a very linear kill chain, right? But we all know that once the attacker is in the network, and they are going to start exploring and to look for new devices to compromise. And that's really where the propagation actually starts. And once they have, compromised, the second device, the attacker is not going to end there, right? They will continue to explore, and then they will continue to compromise the third device. So you can see that, that whole, attack cycle, it's really how we are representing it in this loop.
Well, that makes a lot of sense. It's the old, they used to grab and go, now they come in and lurk, and the loop's meant to show that. The second question was more about the incident correlation part, the big pattern of all the devices and incidents correlated in a nice diagram. What happens if if an event timeline element changes? Are these incidents frozen, or are they immutable in any way? How does that work?
No, I mean, so the thing is, as soon as the first alert gets triggered, it actually, creates an incident. Then the machine learning will dynamically add new alerts as it sees that is actually related to the same incident. So really, by looking at this whole, ransomware, for this dark site, the whole goal is to, by the time before it actually hits the internal SQL dump file execution, or when they are ready to copy the database, somewhere along the line in this timeline, we want to be able to catch that, right? So an incident gets created, with the very first alert, and as it creates more alert, we will dynamically continue to add into the incident. So the analyst that is investigating this particular incident may be catching the attacker at the RDP port opening or the RDP session hijacking.
That's really impactful. I think that helps people understand that can change shifts or come back and look at it later and watch it evolve. And that's it's a living piece of work, just like a real attack. Really cool. Well, look, let's go. Let's close out the webcast. I think we've got a summary slide, Daniel, and we can look for other questions. Okay. And then we'll let people get back to their day. But let's take a look at that, the closing comments from our slideware.
Yeah, so just to recap, what we have shown you today is that with Stellar Cyber Open XDR platform, because of the fact that we can collect telemetry across your entire network, that's going to give that whole visibility. So with that visibility, now we're actually able to, protect, your entire attack surface. We're also going to, because of the fact that we're leveraging, machine learning, we're actually going to be able to reduce the mean time to response as well as mean time to detection. And lastly, the benefit of our platform is that now we're actually going to be able to reduce the cost and simplify the operation because of all the automation that comes with the platform.
That's fantastic, Daniel. For all those on the webcast today, we will wrap this up and follow up with a link so you can replay. And we know our sales team will be excited to see if you're encouraged to have a meeting after today's demonstration. Daniel, thanks so much for your deep showing of the product today and giving us some insights and your expertise. And thanks to the audience for attending. Really appreciate it.
Thank you.
Thank you, Daniel.
Thanks.